All right, in this video, we're going to be going over lesson 8-3, multiplying polynomials, and we're going to start with binomials, right? Two-term polynomials. So to multiply two binomials, you can apply the distributive property twice, or you can cut straight to the FOIL method, which is a variation of the distributive property, okay? So we're gonna start with the distributive property. You can use, once you learn both of these, you can use either method. It does not matter to me. You'll get the same answer at the end, so whichever one makes the most sense to you. All right, so for x plus 3 times x minus 4, we're going to think of this as two terms, right? We've got this first term, which is everything in parentheses, x plus 3, and the second term is everything in parentheses, x minus 4. So basically, we're going to take this first term of x plus 3 and multiply it times x minus, what did I say, x plus 4? X minus 4, right? So that's what they've done here. X times x minus 4. And then the second term in this first parentheses here is positive 3. So then we're going to multiply positive 3 times x minus 4. So they multiplied positive 3 times x minus 4, right? So that's the first step of the distributive property. We distributed both of these to this second term here. And now we can do this distributive property again. So now I'm going to multiply x times x and x times negative 4. So x times x times negative 4. And I'm going to multiply 3 times x and 3 times negative 4. 3 times x and 3 times negative 4. Right? So we just did the distributive property twice. This was step 1, and we simplify, and then step 2, right? This is step 1, this is step 2. And then we start simplifying. X times x is x squared, negative 4x, positive 3x, and 3 times negative 4 is negative 12. And then you're going to combine these two like terms in the middle. So negative 4x plus 3x is negative 1x. And this is your answer at the end. Done. It doesn't have an equal sign here, so we can't solve for x. So we're literally finished, right? The other way is the FOIL method. So they actually used a different set of binomials here. And the FOIL method, which I hope that you've heard of, is first, outer, inner, last. It's an acronym, right? First, outer, inner, last. And I'm going to show you what that looks like. Let's see if we can back up a little bit. All right. So when using this example we have our first binomial and our second binomial, okay? So for first, outer, inner, last, first, we're going to multiply the first term in each binomial. So we're going to multiply x times x. This is the first term here. This is the first term here, all right? X times x. Then we're going to multiply first, outer, the outer two terms, right? There's 4 terms here. Well, 4... yeah, terms. Terms are separated by plus and minus signs. There's an x, a negative 2, an x, and a positive 5. We're counting both of these as terms since they're inside parentheses. This is 2 terms, this is 2 terms, so together it's 4 terms. So the first term in each binomial times the outer terms in the binomial, so the first and the last, so x times 5 up here. Then the inner 2 terms. So first terms, outer terms, inner terms, negative 2 times x. And then the last term in each binomial, negative 2 times 5. So first, outer, inner, last. Does that make sense? The first term, the outside 2 terms, the inside 2 terms, and the last terms. And once we multiply each of those, we're adding them together. Whatever we get when we multiply the first, whatever that is, we're going to add it to the outer. And whatever we get there, we're going to add it to the inner, multiplied together. And whatever we get there, we're going to add it to the last 2 terms multiplied together. So when you do first, outer, inner, last, you're multiplying. Whatever you get when you multiply, you're adding all of those products together. Okay, hopefully that makes sense. So here we have x squared plus x times 5 is 5x plus negative 2 times x is negative 2x plus negative 2 times 5 is negative 10. And then I can keep simplifying. I can simplify these two terms in the middle. Positive 5x, negative 2x. 5x minus 2x is 3x. So x squared plus 3x. If it was negative 3, we'd put a minus sign here, but it's positive 3, so we put a plus 3. And then plus negative 10. Since this is a negative, we put minus 10. All right, we're going to replace our two signs with a minus sign. Replace these two signs with the minus sign. Okay, so x squared, 5x minus 2x is 3x, plus negative 10 is minus 10. And this is our answer. When you multiply two binomials, unless it's a special case, which we will go over in lesson 8-4, you're always going to get a trinomial as the answer. All right, so let's practice. There's a whole bunch of examples here. We're not going to do all of these. I'm just going to do a few. Let's do let's say 4, and then I want to add on the second video. So we'll start with 1, we'll do 6, let's do 10, and let's do 12. We'll just do those. Okay, and I'm going to do it on a separate sheet of paper because I don't have any room to do it on here. All right, so for number 1, we have x plus 2 times x plus 3. Now, I prefer the FOIL method, so I'm always going to use the FOIL method, but you can use the first way we did. That's fine. All right, so the first two terms here are x and x. So I'm going to multiply x times x, which is x squared. Okay, and then I add it to the outer terms. So x times 3, which is 3x. And add that to the inner terms. So 2 times x is 2x. Add that to the last terms. Positive 2 times positive 3 is positive 6. Okay, so we're multiplying together. First, x times x is x squared. Outer, 3 times x is 3x. Inner, 2 times x is 2x. Last, 2 times 3 is 6. Okay, so once I have this, I combine my two like terms, and I get x squared plus 5x plus 6. And that's my answer. Multiply two binomials to get a trinomial. Okay, next we're going to do number 6, and that is 2x minus 1 times x plus 5. Okay, so here, all right, we're going to do first, outer, inner, last. First, 2x times x is 2x squared plus the outside two terms, 2x and 5. 2x times 5 is 10x plus the inner two terms, negative 1 times x is negative 1x plus the last two terms, negative 1 times 5 is negative 5. Okay, so first I'm going to simplify my signs here. So I get 2x squared plus 10x minus x minus 5. And then I want to combine my two like terms in the middle. So I get 2x squared. 10x minus x is positive 9x. And then minus 5. And this is my answer. Okay, next problem. 3x plus 1 times 4x plus 3. All right, first, 3x times 4x. These are the first two terms in each binomial. So 3x times 4x, here, I'll just write it. 3x times 4x plus the outer two terms, 3x times 3, plus the inner two terms, 1 times 4x, plus the last two terms, 1 times 3. Okay, now I just want to simplify. So 3x times 4x, 3 times 4 is 12. X times x, when I multiply bases, I add their exponents. X squared plus 3x times 3 is 9x, plus 1 times 4x is 4x, plus 1 times 3 is 3. And then I'm going to combine my like terms. So that's 12x squared plus 13x plus 3. Hopefully that's making sense. We're just simplifying all the way down. This is our answer. And last one, I said number 12, 5t plus 4 times 2t minus 6. Okay, so first, 5t times 2t plus the outer 5t times negative 6 plus the inner 4 times 2t plus the last 4 times negative 6. Okay, now I can simplify. 5t times 2t is 10t squared. 5t times negative 6 is negative 30t. 4 times 2t is positive 8t. And 4 times negative 6 is negative 24. Then I can combine my like terms here in the middle. I don't have another t squared term, so it just stays 10t squared. I don't have another plain number, so it just stays negative 24. But in the middle, I do have two terms that have a t. So I'm just going to combine them. Negative 30 plus 8 is negative 22t. So those become this, and then I still have this minus 24 on the end. Okay, hopefully that's making sense. I know I'm going quickly, but the rule is the same every single time. So you can use that first distributive property method, or you can use this first, outer, inner, last FOIL method. Okay, so for the second part of this lesson, multiplying polynomials, we are going to cut back to the distributive property. The FOIL method can only be used with two binomials, but here we've got a binomial times a trinomial, right? So we're going to multiply these terms by each, we're going to distribute this guy, this to each of these terms, right? So I'm going to think of this as one thing. So I'm going to multiply 3x times this whole thing. So I get 3x times the trinomial. And then since I have a plus sign here, I bring my plus sign down, and then I'm going to multiply 2 times the whole trinomial. So that's what I have here, 2 times the whole trinomial. Now, once I've got that set up, now it's easy to distribute the 3x and the 2. All right, so 3x times 2x squared is 6x to the third. 3x times negative 4x, 3 times negative 4 is negative 12. X times x is x squared. 3x times 5 is 15x. That's the first part. And then the second part, 2 times 2x squared is 4x squared. 2 times negative 4x is negative 8x. 2 times 5 is 10. Now, there's no parentheses around these, so just because I'm putting these little like things underneath it, I didn't group anything. I'm just showing you these first three terms came from this, and these last three terms came from this. But now we can combine like terms, right? So there's only one term that has x to the third. So that stays 6x to the third. Used it, done. Then I've got two terms that are x squared. So negative 12x squared plus 4x squared. Negative 12 plus 4 is negative 8. And then we still keep that x squared. And then I've got an x term here and an x term here. 15x minus 8x is 7x. And lastly, I've got this 10 hanging off the end, and there's nothing else to combine it with, so it's just 10. It stays 10. So once I've simplified everything at the end, this is my answer, what I get. So I just distributed, that's it. Okay, so let's do that a couple times here, and then we are all done with this lesson. All right, so I'm going to think of the second, here, I'll pick a couple to do. Boom. Boom. Oh, we'll do a trinomial times a trinomial. Sweet. All right, so I'm going to multiply x times this whole thing. X times x squared minus 2x plus 1. And then I've got this plus 2 times, and I'm distributing that 2 to this whole thing. X squared minus 2x plus 1. All right, so if you can kind of visually see it, this first part here, x plus 2, I took the x and multiplied it by the trinomial, and I took the plus 2 and multiply the trinomial. Hopefully you can kind of tell how I distributed this way. Okay, then I need to actually distribute, right? So x times x squared is x to the third. X times negative 2x is negative 2x squared. X times 1 is x. And then 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. And 2 times 1 is 2. And then I'm going to get rid of this because I'm not doing that one. I just need the space. I don't have any other x to the third terms, so that stays x to the third. Do I have any other x terms? Yes. Do I have anything that comes before x? Like if I'm staying in standard form, so I want my exponents to go down in numerical order. Do I have any exponents with a 2? Yes, I've got this guy and that's it. Squared. Oh, this should be 2x squared, just kidding. X times negative 2x is negative 2x squared, just kidding. So I've got this and I've got this guy, negative 2x squared plus 2x squared. They just cancel each other out to 0, so they go away. Then I've got x and negative 4x. So 1x minus 4x is negative 3x. And then I've got this plus 2 hanging off the end. So I'm done. Normally I would have an x squared term in here, but in this case they canceled each other out. Okay, number 4. I'm going to multiply p times this whole trinomial, and then I'm going to multiply negative 3 times this whole trinomial. So I've got p times p squared minus 4p plus 2, and then minus 3 times p squared minus 4p plus 2. I hope you're able to kind of follow along with me and see what I'm doing and understand it, okay? I know for some of you guys, this is like, yes, we get it. Okay, you're saying the same thing. I get it. Fantastic. For people who aren't math-minded, maybe this isn't their favorite thing, it's easy to get tripped up and confused, and that's why I'm repeating it. I get it. All right, so p times p squared is p to the third. P times negative 4p is negative 4p squared. P times 2 is 2p. Okay, then I've got the second part. Negative 3 times p squared is negative 3p squared. Negative 3 times negative 4p is positive 12p. And negative 3 times 2 is negative 6. Okay, so we've got this whole big thing. So now I want to simplify all of that. So I want to say, do I have anything bigger than p to the third? No, and that's the only one. So I'm going to write p to the third. Used it. Then I've got p squared. So I've got negative 4p squared minus 3p squared. That's negative 7p squared. Use those. Then I've got 2p plus 12p, which is positive 14p. And then I've got that negative 6 hanging off the end. So that's my answer. I should have combined all like terms, and this is all I have left. Okay, 2 more, 7. Same thing here. I'm going to multiply 3n times this whole thing. So 3n times n squared plus 5n minus 4. And then I've got this minus 4 times this whole thing, n squared plus 5n minus 4. Okay, so now I can combine like terms. I like having this extra space down here. I just wish this wasn't in the way. 3n times n squared is 3n to the third. 3n times 5n is 15n squared. 3n times negative 4 is negative 12n. Then I've got negative 4 times n squared. Negative 4 times 5n. Negative 4 times negative 4. I ran out of room there. Okay, so first off, I'm going to start with n to the third. There's no other n to the third, so that's 3n to the third. Used it. Then I've got 15n squared minus 4n squared. So that's positive 11n squared. Used it, used it. Then I've got negative 12n minus 20n. That's negative 32n. Used it, used it. And then I have a plus 16 on the end. Done. This is my answer. 4 terms. Okay. And last but not least, number 12 here. I actually have a trinomial times a trinomial, but I'm going to do the exact same thing, right? So I'm going to multiply, I'll try and separate it here, t squared, this first guy, times all of this. So t squared times 2t squared minus t minus 3. Then I've got plus 4t, so plus 4t, and I'm multiplying it also by this whole thing, so 2t squared minus t minus 3. And then I've got a minus 1, so a third term. Minus 1 times this whole thing, 2t squared minus t minus 3. So it actually comes out to be this whole big thing, right? Each of these three terms was multiplied by this guy. Boom, boom, boom. If it helps. All right, then I want to start simplifying. So t squared times 2t squared is 2t to the 4th. T squared times negative t is negative t to the 3rd. Right, this is like a negative 1, so it goes in front. T squared times t to the 3rd. T squared times negative 3 is negative 3t squared. Okay, that's that whole first thing. I'm going to run out of room here real quick. 4t times 2t squared is 8t to the 3rd. 4t times negative t is negative 4t squared. 4t times negative 3 is negative 12t. And then lastly, negative 1 times 2t squared is negative 2t squared. Negative 1 times negative t is positive t. Negative 1 times negative 3 is positive 3. It's kind of big. I gotta combine all this. All right, so looking at this whole thing, it looks like the biggest exponent I have is 4, and I only have one of those. So 2t to the 4th, done, used it. Then what do I have to the 3rd? I've got negative t to the 3rd, 8t to the 3rd, and that's it. So what's negative 1t plus 8t? Positive 7t. And it's t to the 3rd, not just t. So I use this and I use this. Then I've got t squared. So I've got negative 3t squared, negative 4t squared, and negative 2t squared. Negative 3 minus 4 is negative 7. Negative 7 minus 2 is negative 9t squared. Boom, boom, boom. Then I've got t. So negative 12t plus t is negative 11t. And lastly, I've got this plain number hanging off the end, which is just plus 3. So this whole thing is my answer. 2t to the 4th plus 7t to the 3rd minus 9t squared minus 11t plus 3. All like terms combined. If you have any questions on distributing or multiplying polynomials, please, please, please email me or Schoology message me and let me know so that I can explain it another way or send you some resources that maybe show you a different way to do it so that it clicks. But it really is just distributive property. That's it. Okay? Good luck.